Yes.
Yeah. Okay. Good. So you may have caught a little bit of the tail end of the discussion there, Rich, and I were having about branding and things like that. So the company I work for was until recently called nCipher Security, and we were acquired more than a year ago by Entrust Data Card, and Entrust Data Card just recently rebranded to the shorter version, Entrust, and we're also rebranding to Entrust. So we're dropping the nCipher name, but keeping the nShield product name. So I'll talk about that in a bit more detail, but really this presentation is focused on not so much, it's not intended to be a commercial presentation, it's more an educational one. Feel free if you have questions to stop as we go along, because we've got a reasonable amount of time today and I want to keep it informal. We've got quite a sort of a small group, so we can easily have questions along the way if you care to ask them. So with that, I shall find the right screen here so I can control the slides. So I want to talk about security microservices, and it's really a trend that we're seeing with a number of our customers, particularly some of the larger customers in the banking space, for example, are doing things in this way. And I think it's an interesting trend that combines a couple of things, the trend towards microservices and some changes to how people are using security functions and things. So security microservices are microservices that provide security functions. I'm not talking today about how you go about securing a microservice or a set of microservices. I'm talking about microservices that actually provide security functionality to the calling applications. So if I can jump to the next slide. So, there's a lot of reasons why people are using microservices, and microservices could be for a range of different sorts of things. They could be for, for things like identity and access management, security, I'll come back to obviously, but things like big data, AI, analytics, etc., messaging. There's a whole range of different things that could be there that I haven't mentioned, but I'm sure you're probably familiar with some of the microservices that are there. And some of the reasons why people are using microservices is it really allows people to build a rich set of features and then share that between a range of different applications, which might not be possible if you were going to try and build those particular rich features into, excuse me, into each application itself. So it sort of reduces the size of the software stack, it makes it cost effective, and it also means that you probably get a richer feature set than you would if you were going to purpose-built that for a single application. And of course, a lot of the microservices people are using are ones that are provided natively by the cloud service providers rather than actually microservices they build themselves. But some of the larger customers, large corporates, for example, also build microservices internally that they then use across a range of different businesses within their organization. So one of the things that it also allows is it's easier for applications to consume those services, because rather than having very customized things, you can use pretty standard sort of interfaces using REST APIs, for example, or SOAP, and possibly using Open API. They typically run across HTTP with TLS, HTTPS, so that it's a secure link. And they often use formats like JSON or XML to actually structure the data that's being transferred. So it's both machine readable and human readable, which makes it easier to debug things and things like that. And with that, then they get a lot of resilience, they get fault tolerance, scalability, in this sort of serverless approach. You're probably familiar with that from the cloud vendors offering serverless services. And of course, obviously there are real servers behind there, but the point is that the complexity of how you set up those services, scaling them out, how many physical servers you need, all that sort of stuff is handled by the microservice provision. It's not handled by the application itself. It doesn't have to worry about those sorts of things. So one of the other things that we're seeing quite interestingly is this point about separation of responsibilities and expertise. So particularly when it comes to things like security, there's a lot of expertise, as we know in this industry. There's a lot of expertise that is there in the security people and the personnel, the security departments and things that may not be shared by the particular business lines and their application development teams and things. So you can get the ability to do things in a more secure way using best practice, etc. That may be not as easy for a team that's not really very savvy on security to do. So the security team can look after the security microservices and the applications to consume them. And one of the things that interestingly we've seen with some of our large customers too is that sometimes these application providers in their different business lines, rather than following the rules for security microservice for security that were sort of the corporate standards for applying security, they went, oh, look, it's too hard for this, and for these reasons we want an exception and a waiver, etc., etc. And often in the past, because of the difficulty of building specific security services for each application, they've gone, okay, well, this one isn't particularly high risk, so we'll give you a waiver, you can do it in a different way, that's okay. But since they've put in security microservices, they've effectively been able to say to these application guys, hey, it's simple for you to call it. You don't have to build all this extra functionality, have all these extra software in your software stack. Just call these services and call on it. So we're not going to give you a waiver. You have to comply with the corporate standard, and therefore they're getting much better compliance around security issues by making it easier for the applications to consume the security services. So what are we talking about with security microservices? Well, it's things like encryption services, authentication, digital signing, that sort of thing. And what should really happen here, and in the best case, of course, they're underpinning that by using hardware security modules. And I'll talk a bit about why hardware security modules, just as a bit of background before we get into a bit more discussion about security microservices in more detail. But if you think about microservices, security microservices, and what sort of cryptographic security might be there, it's probably worth thinking about for a minute about what sorts of applications actually need cryptographic security. So things like database encryption, file encryption, digital signatures and certificates. Someone's not on mute, and it's sort of noisy in my ear with a bit of background noise. If you can just mute yourself if you're not talking, thanks. And one of the other areas is in terms of things like IoT device certification. Thanks for muting. If you produce IoT devices, or in fact devices for even things like subsystems for mobile phones and things like that, often each individual component actually has cryptographic keys and that are unique to each particular item, and they need digital signatures, digital certificates, so that they can actually authenticate themselves to other subsystem components and things like that. So there's a lot of crypto in IoT and in mobile devices and other subsystems and things. There's also lots of crypto, of course, in blockchain, and blockchain, of course, is more concerned about the integrity of the blockchain. So you're using cryptographic checksums like message authentication codes, digital signatures, that sort of approach of cryptographic authentication. And the blockchain itself is not using encryption because it's not encrypting the data in the blockchain. The data in the blockchain by its nature has to be readable by everyone. So the data is not encrypted. What you have is message authentication codes that look after the message integrity of each thing in the block. And of course, each block is then cryptographically chained to the next block, which is why it's called blockchaining. And of course, you can link to confidential data that isn't on the blockchain, so that you can use things like a hash to effectively include something in the blockchain that's not actually in the blockchain itself, but you can prove that a particular document was attached to a particular transaction or was around at a particular point in time. So there's a lot of cryptography in blockchain as well, but not encryption, but more message authentication. And digital payments, obviously, there's a lot of crypto in there. So a lot of the cryptographic services people want to use are around digital payments. And that's that if we didn't have cryptography, we effectively wouldn't have all of our digital approach to payments that we're so used to today, and ability to use online cards, ability to use NFC-based payments on our phones and watches and things like that. That wouldn't be possible without cryptography. Probably one of the major uses we see is for the TLS protocol, which superseded SSL, of course, and that gives us a huge amount of security because we can log into websites and things and secure those. So the TLS or SSL should be ideally using hardware security modules to underpin that, or hardware devices at the client end as well. And a lot of these things use PKI. PKI is increasingly important. It's used more and more, but it's sort of under the covers, so you don't see it as much. To give you just a quick example of how it's sort of grown in use in a modern mobile phone, all the subsystems cryptographically talk to each other and all have certificates with PKI, so that each subsystem can be authenticated. So if you're probably aware, if you take your phone for repair, it has to be repaired by an authorized vendor who can give an authorized part, because the other components in the phone will actually want to authenticate that that's a genuine part, etc. And that's all based on PKI. So there's lots and lots and lots of certificates in each mobile phone that you're carrying in your pocket, and that's something that's not necessarily visible to the consumer, but it's there, and it's increasing in usage. So again, I know I want to get back to microservices in a bit, but I just want to explore some of the background as well. So I want to talk about why hardware security is important for cryptography. And effectively, if you think about, if you've got a software-only solution, then you've got to have cryptographic keys in the CPU to actually use them. They need to be sitting in memory to be used. They therefore have to be in storage, and in storage they could be at all different levels of your software stack. They may end up in backups. They may end up in live VM migration, for example. So if you've got a software environment, you really end up with the keys being exposed, and you're really relying on all your software-based controls to try and limit access to prevent any sort of misuse of those keys. Effectively, you might sort of say, well, if I've got a key, why don't I encrypt it under another key and protect it that way? And of course you can, and you do. And you may then say, well, what about the key, the master key that protected those other keys? Well, I can encrypt that as well. But obviously, at the top level, you've got to stop somewhere. What do you do with the top level key? You've got to have that somewhere, and you've got to have that available. So, ultimately, you're going to have a key somewhere, even if it's protecting other keys, that is potentially vulnerable to attack in a software-based system. So if you add a hardware device like a hardware security module, then effectively the keys are only ever in the clear inside the hardware security module. So the application, the subsystems here are all calling on the hardware security module to do things with the key, encrypt data, decrypt data, validate signatures, validate authentication codes, those sorts of things. And they do that in a way where an authorized process can call on the hardware security module to do it, but the keys it's in a separate physical device, and the keys are there, and they're never exposed in memory and in the backups and in all of the other levels of the hierarchy here. So in that sense, you always know where your keys are. And this, I'm talking about hardware security modules here, but there's other types of hardware security devices as well at the client end, for example. So that's effectively why hardware devices are important. It's very, very, very difficult to give high assurance around cryptographic security unless you've got some hardware to protect the cryptographic keys. One of the ways we've got a good, nice, fun sort of video on our YouTube channel that talks about this and uses a character, Barry the burglar. You know, basically, if he's trying to break into your house, he'll probably look under the mat and see if the keys are there, or look in the flower pots or something like that. So it's a bit like that if you're trying to hide your cryptographic keys in software and not actually protect them properly with a hardware security device. It's likely that the burglar can find the keys under the mat. As I mentioned, we're rebranding, so if you use the product branding nShield rather than nCipher to search, you'll find it more easily there. But I recommend that. We've got a number of other quite fun videos there on YouTube channel as well. So just to give you an example of where hardware security devices made a big impact, you might remember the Heartbleed bug from a few years ago. So what this was that in the OpenSSL code, someone introduced a bug inadvertently that was only discovered about 2 years later, and you know, well, discovered publicly anyway. We don't really know whether the black hats or the NSA or the Russians or the Chinese governments managed to find it before that, but it wasn't publicly disclosed until much later. And effectively, what that bug did was that there's a heartbeat message between a client and a server. This is a simplified example of what it does, thanks to a very nice graphic on Wikipedia. And effectively, the client sort of says to the server, "Are you there?" by saying, "Hey, repeat this word after me. Are you there? Bird. You know, here's a 4-letter word, bird." And the server goes, "Bird," back again. So you go, "Oh yeah, the server's still there. It's still alive. That's the heartbeat." Now, with the bug, in the malicious usage of that, if the client sort of said, "Send me this 500-letter word. Are you there? Bird," the server would send back, 500 letters rather than just the 4. And that meant that you could pull cryptographic keys out of memory on the server. And it was pretty catastrophic bug, actually. Fortunately, it was discovered before it seemed to be in wide sort of use for attacks and things like that. But that bug was sitting around there for a couple of years undiscovered. And this is the problem you have with software-only security, is that you might think you've covered all the options in terms of access control to your keys and things, but unless you really can't be sure, because software, unfortunately, is full of bugs. There's a lot of economic incentives on programmers and companies creating software to get it out quickly and not spend massive amounts on testing and things like that. So that has generated a situation where software is not very dependable. Things have got a lot better in recent years, of course, particularly thanks to the efforts of Microsoft, etc., to really focus on improving security and pushing out secure development lifecycle approaches to the market as well. So things have certainly got better in that regard, but software is extremely complex. It's full of lots of different systems, lots of different sources of the code that goes into any one system. So being sure that it's all safe and secure is very, very hard, so that you really want to base things on hardware. So if you think about the situation then where you had Heartbleed and the bug in the software, if you had your OpenSSL implemented using a hardware security module as the place where the keys were, and the OpenSSL software was calling on the hardware security module to do the cryptographic functions, then you can see that this sort of attack would never cause any problem because the keys were not there in memory in the first place. So that's the real difference between having keys in a hardware security device versus having keys in software, where you're relying on there being no bugs that are going to expose those keys. So what do we mean by hardware security modules? So we're talking about physical appliances. Our devices are, 1U appliances that sit in a rack in a data center, and they provide high level of protection. They're certified to FIPS 140-2 or 140-3 is coming, and also to common criteria standards as well, so that they're independently certified by third parties. Both our equipment and, of course, our competitors as well, they all take the same approach of independent certification, etc. They implement and enforce defined policies and effectively harden your cryptography. And another important aspect of hardware security devices, HSMs and other devices, is that they are a source of high quality random numbers. So if you are going to generate cryptographic keys, you want the seed information for generating of those keys to be extremely random, because if it's not random, then the random number approach becomes the point of attack, rather than you certainly wouldn't try and crack the cryptography. But if the keys are in some way predictable, then that's going to be the place that the attackers are going to try and get to. So within hardware security modules and some other hardware security devices, they use a hardware rather than a mathematical sort of pseudo random number generation process. They're actually using a true hardware security hardware random number generator, which is effectively just electrical noise based on heating and radiation from space and various places that causes the random values to be generated. So it is truly random. So that's another very important thing of hardware security devices. So in our case, we also do the hardware security devices in different form factors, in a card that can go into a server or a workstation, the network connected devices, or small USB connected devices for certain applications. So as I've mentioned a couple of times, it's not just hardware security modules that are hardware security devices, but things like smart cards and SIM cards in phones, USB tokens that act in the same way. You're probably aware that there's chips in your ID card. For example, there could be, so there's a lot of smart card and smart card related devices out there. There's also secure elements or secure enclaves within mobile phones that act as a sort of a mini hardware security module inside each phone. And on laptops and servers, you can have trusted platform modules that also provide cryptographic protection of the key, although they tend to be much lower in functionality than secure elements, even smart cards. And certainly if you're talking about much more comprehensive controls and things, then hardware security modules provide a lot more functionality and a lot more complexity there. So effectively, you've got hardware security modules for the back end, for the host server end, and you've got smart cards or secure elements or TPM chips for the hardware security devices at the client end. And that's really what's important. So when I say we need hardware, I'm not just talking about the back end, but also the front end as well. And certainly all the mobile phone manufacturers recognize this, led of course by Apple. Apple's very mature in its approach to cryptography, and it's very, as you're probably aware, does things pretty well in terms of securing their devices. And of course the other manufacturers are also very strong in that space, be it Samsung, Huawei, etc. Yeah. So in terms of connecting to a hardware security module, the typical approach is based on various industry standards. So things like PKCS11. I lost my pointer. Where's it gone? anyway, PKCS11. Here it is. I don't know why my point, there it is. Yes, so PKCS11, which is a set of cryptographic, which is public key cryptographic standards number 11. They came out some years ago, and they've actually been standardized as IETF standards as well. There's the Microsoft cryptographic API that's been there for a long time, and that was replaced and superseded by the cryptographic new generation library. And this is the one that is most used, but of course some older software still expects CAPI to be there. There's also the Java crypto engine, which a lot of Java applications use. There's some other things like the Chill engine, etc. There's other things as well. On our software, we provide a sort of a native library that has much higher functionality, and then we also, these front end APIs sort of sit in front of that and call the native library itself. So applications can call either the any of those industry standard APIs, or they can call the NCore API directly. So that's how the standard approach works. So effectively, on the server that you want the application to use the HSM, you need to install the software there to talk to the HSM. I just seem to have got PowerPoint crashing on me, has it? Or is it working? Sorry, I think I need to restart PowerPoint. Apologies, give me a second.
Yep, no problem.
Just what you want in the middle of a presentation here. So just coming back to there. So effectively what, let me see if I can get my laser pointer back again. Okay, so effectively to use, I don't seem to, the laser pointer is not working too well. Okay, can you see my pointer here?
Yes.
Okay, I'll use that instead. It seems to be a bit more stable. So on the server where the application sits, you normally have to install some software that allows it to talk to the HSM, and that's how the standard approach to using HSMs, not only our HSMs but our competitors as well. So what we can do in terms of, I don't believe this, I'm just getting PowerPoint crashing again.
Maybe it's because of the laser pointer.
Yeah, I'll stop trying to use that. But it may be because it's also got, let me just shut some other things down.
Okay, while we are waiting Ian to fix some issues there, I'd like to say a few words. So I'm Anthony, chairman of Cloud Security Alliance Hong Kong and Macau chapter. So I'm in these last 2 weeks of 2020, we still had everyone online and enjoying this knowledge sharing sessions, which have been helping us with one thing, knowledge sharing session every month. And usually we get 30 to 50 members joining, and then it's very, the most, I would say, well participated events in our chapter. So we are now planning for the next year's events. So if you have any idea or would like to nominate some speakers to present at this knowledge sharing session, please reach out to Richie or me. You can message us on this chat room, and we obviously will plan ahead for 2021. I believe remote session for 1 hour is quite a convenient and productive way for us to collaborate and share knowledge. So that would be, I mean, continue forward in 2021. That would be a major event for us. So Ian is.
Yes, I think I'm back again. Thanks, Anthony.
Okay.
I hope
Okay.
it's.
So
can you still see the screen?
Yes.
Yep.
Yes.
Okay.
Good.
Great. Thanks.
So go on with your presentation. Thank you.
Yeah. Sure. I just also forgot to point out on here that the communication between this software and the HSM is secured as well by using our so-called inter-module path software, but it's sort of effectively like similar to TLS protocol. So if we then think about and of course you can run. I forgot that bit. You can run multiple servers talking to a pool of HSMs, for example. So if we're talking about turning that into a microservices architecture, effectively what we would do is have a microservice software stack in front of this that is talking to these interfaces, possibly, one of those, and then you would have the applications using a TLS connection using various protocols, whether it's in various data structures, JSON, XML, REST APIs, whatever, to talk between the applications and the microservice stack. So it acts as an intermediary. Now, one of the benefits of this is that the applications don't need to install any of the software to talk to the HSMs. They can call just using standard software. They can talk in REST, JSON type approaches, or use SOAP or whatever you want to use, and they can talk in that way, and it takes away a lot of the complexity out of the application, and you can keep the security there by using TLS between the application and this microservice software stack, and the TLS at this end can be protected by the HSM. And obviously we have a option pack to support that. Some of our customers do their own approaches here, and some are using our provided option pack to provide a set of microservices that expose some of the HSM functions as microservices. So taking a different sort of view of this, if you like, more or less the same thing, you can have different departments talking to a range of different microservices, including microservices for security. And these security microservices then can be run on servers here that are running, say, a REST API. You can have this in a high availability cluster of multiple HSMs, multiple front ends here, so that you get a lot of resiliency and so on. And importantly, you can have this whole thing set up, run, maintained, and supported by the security team rather than the application teams in the organization. And that's something that, as I said before, some of our customers are really seeing a big benefit, and the ability for the security team to say to these departments, no waivers, you have to use the services, because we've made it very easy for you to actually use those services directly. So, and again, of course, one of the options here is to use our web services option pack. So I want to give you an example of one of the sort of use cases for that that we've been actively working on, something that I'm personally involved in with a number of our customers. So effectively, what often happens when you've got a browser or an app talking to the business, the customers need to log in, so they put in passwords. The password is passed over a secure connection using TLS to the web server, and thereafter, and the sort of the problem that you have is that the termination of TLS happens quite early and quite at the front of an organization in a load balancer or a web server, often in the demilitarized zone. So the question then comes that this password that was secured using TLS between the app and the web server, or the browser and the web server, what happens to it once it gets inside the organization? Is it vulnerable to being attacked then? Is it unencrypted, etc.? So you've got the situation that all of this inside area, inside the organization, you may have some vulnerability there, that login credentials and other data that you're trying to keep secure may be exposed there after it sort of leaves the protection of TLS across the internet. So the solution that we've implemented for a number of clients is that we've got HSMs to do the specific functionality around validating passwords and checking other things, changing the way in which the passwords are stored and things, various other things that can be done in a custom way for particular customers as well. So they're doing that using microservices here, which means that different applications within the particular organizations, and in most of our customers for this are banks, so they've got different business lines, different aspects of the business units of the bank that all have requirements for different apps and different different passwords, different back-end systems that they're trying to actually log into. But we can provide a set of security microservices here that are based on the HSM that allows us to pass the encrypted passwords all the way through to the HSM, and the encrypted password is only ever in the clear inside the HSM, and it's checked against the hash that's on the user directory, and because that's also passed in to the HSM and it's checked inside the HSM. And we can also do this for things like one-time password keys, to allow setup of one-time password keys out here. We can do it for payload data, where you want to pass it through to a back-end system and decrypt it and only store it at the back end, only decrypt it at that one system at the back end, and not have it exposed through the rest of the infrastructure inside the organization. So to put this in more of a schematic form, what we've effectively got in this particular solution, we've got an application SDK for JavaScript, iOS, and Android, and that helps package up into an encrypted and authenticated blob, put the password or two passwords if there's a change password request, and that is encrypted at the client in the browser or the mobile app, and it's sent all the way through into the HSM to do the decryption. And we've got some customized software also running within the boundary of the HSM as well. The way our HSMs work is that the standard cryptographic functions, which are certified for FIPS, etc., are protected within a boundary, and you can add additional software here which doesn't affect the FIPS certification of the HSM, but it runs within the HSM and it's protected by the HSM, but it doesn't change the core functionality, so it doesn't change the FIPS certification of the HSM. So effectively, through the application servers calling the JSON REST API, and that calls either code-safe software, the software that runs inside the HSM, or calls the standard functions, and the code-safe software can also call the standard functions as well. So that's what that solution looks like, and we've found that's quite useful, particularly as some of our customers are under pressure there for compliance reasons to do end-to-end encryption. There's certainly strong requirements from the Hong Kong Monetary Authority on that, on the Taiwanese regulators, also from Thailand and Singapore and various other players, etc., are looking for that sort of end-to-end security around those things. But whilst this has got a lot of penetration into the banking sector particularly, it's also applicable to effectively any other sort of organization that's having people log on through apps or browsers, etc. So that's an example of where security microservices are being used. I'll just mention a couple of other things we're doing. You might have wondered sort of what happens when you've got physical appliances like HSMs and everyone's talking about cloud and trying to move away from data centers. Well, one of the ways we support that is having the ability for people to use our HSMs remotely as a service, and we host them and manage them, and there's different types. The amount of management we do, whether it's just the physical side of it or whether there's some aspect of the security administration as well, there's a couple of different levels of service there available. And so that's one way to do it. The other thing that is fits things more into the modern age, you're probably aware that everything's going containers, and we've got support there to allow people to use containerized approaches to using HSMs, regardless of whether they're physically there or in the cloud. And it's another way you can actually build microservices by using containers to build those microservices. So as I mentioned before, our branding was nCipher going back sort of about 20 plus years. We were acquired by Thales about 10 years ago or 12 years ago or something. And we were inside Thales, as you're probably aware, and a lot of people know our HSMs as Thales and Shield HSMs. Thales then acquired SafeNet, Gemalto, and therefore we were separated out and we were acquired by Entrust Datacard. Entrust Datacard became just branded as Entrust, and our branding is also moving to Entrust. So if the Entrust brand is not familiar to you, Entrust has been around in the PKI space for a very, very long time. It's one of the earliest and most trusted PKI vendors globally. Then some 5 years ago, I think it was, Datacard, which you may know for their production of banking cards and various other types of identity cards and things, it acquired Entrust, and the company was rebranded as Entrust Datacard, which is rather a long name, and we've recently shortened that name to Entrust, and now the nCipher is also now rebranding as Entrust as well. So that's just a bit of history there, and I'm part of the professional services team for Entrust. We do things like PKI professional services. We can do product deployments around our own products and things, and provide cryptographic solutions like the one I was just talking about for the banking passwords, etc., and also do training and certification. So that's what I had in my main presentation. We've got about 15 minutes left. I've got some other material I can dive into, of course, but I wonder if there's any questions.
Any questions from the audience? Usually the facilitator got some good time that I can ask questions if in case someone no one asked any questions. So I think one of the interesting point which Ian, you mentioned, is about the nCipher as a service. So that's mean the cloud user can use your solution as a service mode. But in that case, is it all the cloud service provider? I mean the bigger one, like the AWS, Azure, and maybe Google Cloud as well, or Alibaba Cloud as well. So is it all of them can use this nShield as a service? And also, if using this nShield as a service, any particular settings they need to configure or set before they can use this service?
Thanks, Richie. So I suppose just I'll answer in a little bit of a roundabout way. All of the cloud service providers use HSMs to provide their services, including key management services, and a lot of the cloud service providers also provide HSMs as a service, that you can rent their HSMs as a service. Microsoft Azure uses our nShield HSMs as the main HSMs it uses at the back end, and we've worked closely with Microsoft over the years to provide an ability for customers to use our HSMs in premises and use a bring your own key approach where they can interact with the nShield HSMs inside Azure and pass keys between and so that the customer can control the use of those keys in a tighter way than just leaving it up to the cloud service provider's approach. And we've also got integration packs for Google Cloud and for Amazon Web Services as well. So all of those cloud service providers have HSMs at the back end that are protecting keys and providing cryptographic services to provide the various approaches they use, log on, secure authentication, all those sorts of services that they need, dedicated key management services that you can call on, etc., and also cloud HSM provision as well. So we sort of fit into that space largely because what tends to happen is that most customers these days are using multiple cloud vendors in parallel, at the same time. They may be using a hybrid approach of using on-premise things as well as public cloud as well. So you get these hybrid approaches, hybrid public and private, and also hybrid between multiple cloud vendors. So what people often want is the ability to have an approach where they can move things between different cloud vendors and have an approach to security that is a little bit independent of the cloud service providers as well. So it's all about owning your security and providing a lot of control there and flexibility between moving between different cloud vendors. So this particular service uses our secure data centers currently in the US and the UK. We're looking at other locations as well. And effectively what you do is you lease a physical HSM and you can use it just like it's in the next room sort of thing. Obviously, there may be some latency differences, but often latency is actually pretty good even around the world, we found. But typically, it's not latency that's the issue, it's throughput. So effectively, what you want is to be able to queue up multiple transactions, and you don't sort of ask a question and wait for a response before you send the next question. You send question, and the responses come back asynchronously, and therefore you can get very high throughput. So to give you an example, at the high end, our devices will do more than 8,000 2048-bit digital signatures per second. So you certainly don't want to be asking one question and waiting for the response. So the latency is less of an issue than the throughput, and you can get through high throughput even if it's at the other side of the world. And the other advantage we're finding is that people can, because you've effectively got exactly the same thing, it's just remote, they've got easy ability to just add nShield as a service HSMs into their existing physical HSM pool in their own data centers, and they behave just the same. So you can share keys between them and all that sort of thing as well. Does that answer your question, Richie?
Yeah, I think definitely this type of key management as a service would be the future. Especially when we observe that more and more customers are actually using more than one cloud service provider and also having their on-premises environment. And in fact, when we try to use the recommended key management services from the cloud service provider, most of the time what we encounter is that we cannot export the key out from the cloud service provider environment. So it would be an important point for us to explore in the way that how we can manage the key outside the environment, which is just on the cloud, just on one cloud service provider environment. So I think this would be rather interesting and good to know, especially how to integrate and use it, because in some way it seems that it's not easy to find across all the cloud service provider, how we can make use of this services.
Yeah, and that's definitely why a lot of our customers want to take something that's independent of the specifics of each cloud service provider and do something separate. A lot of them also want to run key management systems that support the KMEP protocol, for example, the key management interoperability protocol, because a lot of devices use KMEP, and so KMEP servers or key management servers supporting KMEP and other protocols then rely on HSMs to protect at least their master keys, but maybe more thoroughly as well. And they can be hosted potentially as virtual appliances in the cloud and supported by a physical HSM as a service or in your premises. Yeah.
Yep. And another question. Right now, any other audience? Any questions you have? If you want, you can ask questions as well. Eve asked a very tough question to you, Ian. She asked a quick question. She mentioned that any impact to deploy HSM in Hong Kong with recent US sanction?
Good question. No, not that I'm aware of specifically at this stage. Yeah. But we do, for example, also sell HSMs into mainland China under specific circumstances. Bit of a, as you, it's a long story about cryptography exports, because they tend to be controlled a bit like weapons sometimes. So governments have a lot of controls over cryptography. But effectively, in mainland China, for example, we can sell our solution where the mainland Chinese firm is using the HSMs to talk internationally rather than domestically in mainland China. In mainland China, they have their own requirements around algorithms and those sorts of things that don't interact with the international community. So it depends on whether it's international business or domestic business, whether or not international HSMs are applicable in mainland China.
So you touch on to another interesting point. I don't know if you specialize or expert in this part, but one thing is if what you mentioned, the China right now, then for your solution, say nCipher as a service, can it be used in mainland China?
I am not exactly sure the answer to that one. I'd have to check. Yeah.
Yeah, no problem.
It may well be. I think it can be under the same sorts of circumstances as I mentioned. It has to be. The Chinese firms need particular licenses from the Chinese government to be able to use international HSMs, but the same would apply whether it's local or not. Yeah.
Yeah, because it somehow, if we advise some of the customers to use the nCipher as a service, then some of them may be crossing the district from Hong Kong to mainland China, and so that may usually be some of the questions that they may want to know. Yeah. So any other questions? Any other questions? You can either drop it in the message box, or you can ask directly.
I'll answer Henry's question in the question box. Yes, I can provide the presentation. I'll get, I suppose.
Yeah, you can pass to us. We post it in the website. So
yeah. Okay.
Thanks.
Good.
Thanks. So another thing which Ian, you mentioned earlier is about the security microservices, that the solution that you mentioned earlier. So if a company is going to use this security microservices, then what things they need to change in their application or programs in order to ensure that they can support this microservices?
They would need to make the calls to the microservice. So they would have to change their code, yes, to do that. But they should, it's often most applicable when customers are already writing custom code to do things. That's where I see the majority of the use cases. So these applications need to do something that, if you're talking about like, there's a lot of products that just out of the box, of course, can use HSMs directly, from a whole range of things, from in all sorts of things like database encryption, privileged identity management, like CyberArk and things like that. There's hundreds of things that can use HSMs just out of the box without any customization of the software. But if you're talking about consuming security microservices, at the moment they're mainly going to have to be customized. There are some standards emerging, but they're not really mature.
Sorry, maybe I didn't explain it clearly, because I'm thinking that, say for example, if the company actually originally what they were writing were just using monolithic kind of program, then if they want to make use of the security microservices, do they need to change their entire set of code from the original monolithic kind of programming to microservices before they can make use of your security microservices environment? Or actually that we can consider this security microservices part as a separate and can be considered as isolated from the application. They can, when whatever they can communicate through the RESTful API service, then they can already communicate with your program.
Yeah, that's an interesting question, actually. I hadn't quite thought about it in those terms, but I guess in this sort of scenario where these applications are already calling a whole lot of other microservices, then calling security microservices is fairly easy. If the only thing they're going to call is security microservices, it may be easier for them to call the PKCS11 or CNG or something like that APIs instead, or the Java API. It just depends on the circumstance. I agree that there's a degree of setup needed for calling microservices. You've got to have the infrastructure here to talk HTTPS to arrange the different things and the configuration and all that sort of stuff. But there's software stacks, etc., out there that do that. So I would say, short answer is, for people who are already using microservices, then security microservices may be the easiest way to consume HSMs. For people who are not using microservices already, they're probably better directly connecting to the HSMs.
Okay, so thanks for your input. Any other questions? Anyone got any questions that you want to ask? So if not, it's 1:30 already, and really thanks, Ian, for your great presentation, and that definitely it's helpful to all the customers, and if we have chances to that we need to ask you further, and do you have any emails that you want to share so audience can communicate with you?
Yes, sure. I should have put that in the thing. It'll be in the hardest part about my email address is just spelling my surname. So if you can get if you can get that bit right, you're probably fine to contact me at ian.christofis@entrust.com. I'll just pull up the front page again, so you've got and as I say, we'll have the we'll distribute the presentation, but ian.christofis@entrust.com is the way to get hold of me. Good. Or if you're really stuck, ring Richie or Anthony or Harry. They all know me well.
Yeah, and in fact, Ian is also our council member of Cloud Security Alliance as well. So thanks again for Ian for your presentation, and also thanks everyone for joining this today's event. And the next time when we have the event, it will likely be passing through the New Year time already. So wish all of you have a Merry Christmas and Happy New Year as well. Okay, so thanks a lot. Thanks a lot.
Thank you. Thank you.
Thank you. Merry Christmas. Bye-bye.
Bye.
Bye.